A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Hello once again. Thanks for joining us. I hope you had a great weekend. Andrew Dunkley here, the host of Astronomy Daily. And my partner is, as always, Halley, our AI reporter. Hi, Halley.
Hi, Andrew. You've had a lot of rain in Dubbo, and I've been watching the flooding in your area on the news. I hope you've been okay.
Yeah, thanks, Halley. We got a massive amount of rain between Wednesday and early Sunday morning, about 106 millimetres, which is well over 4 inches in the imperial scale. And yes, after all this time dodging bullets, we finally have had moderate flooding in Dubbo and up and downstream of the Macquarie River. But there are a couple of evacuations, nothing too serious, but lots of road closures because we've only got 2 bridges that cross the Macquarie River. One of them's a low-level bridge, and it unfortunately went under. So all the traffic had to be diverted through town rather than around the outside, and that caused absolute mayhem. But at least our problems were only fairly isolated in terms of traffic. That low-level bridge is likely to open up again probably in the next 24 hours, so things might start to get back to normal fairly quickly. And better news still, we don't appear to have any, not a lot more rain coming this week, maybe a bit on Friday. So fingers crossed that we've passed the worst of this one, but that doesn't mean we won't get another one because all the rivers and creeks and soil is charged with moisture. So everything that hits the ground runs straight off. But on my side of town, we're on the high ridge. So if we got flooded, we'd have to wave to Noah. So we're kind of lucky here.
Well, I'm glad you're high and dry and hope that everything gets back to normal soon.
Thank you, Halley.
The Astronomy Daily Podcast with Andrew Dunkley.
How about we get the news?
Sure. A Chinese spacecraft has taken off with the goal of studying the sun to improve space weather predictions. The satellite, known as the Advanced Space-Based Solar Observatory, lifted off on Saturday from Jiuquan Satellite Launch Center in Inner Mongolia. The ASOS spacecraft, nicknamed Quafu-1 after a giant in Chinese mythology who chased the sun, was deployed successfully into its target orbit, a sun-synchronous path about 450 miles or 720 kilometers above Earth. The ASOS mission was first proposed by the Chinese heliophysics community in 2011, according to the Chinese Academy of Sciences. The 1,960-pound, 888-kilogram probe will use 3 instruments to study the sun's magnetic field, solar flares and coronal mass ejections. Solar flares are often associated with coronal mass ejections, and both can affect us here on Earth. Powerful CMEs, for example, can spawn geomagnetic storms that can disrupt power grids, radio communications, and GPS navigation, just like the one we reported a couple of weeks ago. The ASOS mission is expected to take 4 years. Still on the sun, although that would burn your feet I guess, an astrophotographer has captured an astonishing image of a massive plume of plasma shooting out of the sun. The coronal mass ejection extended into space to a distance of more than 1 million miles, 1.6 million kilometers from the sun's surface, according to the photographer. The image was captured by professional astrophotographer Andrew McCarthy, and he shared the stunning view on Reddit in the subreddit r/space. The CME was part of a minor G1 class solar storm, the lowest category on the National Oceanic and Atmospheric Administration's geomagnetic storm scale, and was pointed away from Earth, according to spaceweather.com. The plasma was initially contained in a large loop connected to the sun's surface, known as a prominence, and then broke off and streamed into space at around 100,000 miles per hour, or 161,000 kilometers per hour according to McCarthy. A new piece of kit has at the University of Chicago campus in Hyde Park. The object is a telescope reflector made from two 20-ton blocks of aluminum. It came to the U of C campus Friday afternoon for installation in the new High Bay Research Building for Physical Science Research and large-scale device fabrication. The reflector was shipped from Germany in an old-fashioned literal sense. It was too big to be flown across the Atlantic on an airplane, so it was hoisted onto a ship. The reflector found its way to Gary, Indiana, where it began a journey on a truck. Its surface had to be mapped precisely with a laser to ensure the shape is exactly what is needed. The shape must be precise down to tens of microns or the width of spider silk. The reflector is part of a larger project called CMB S4, which U of C received a $4 million award from the National Science Foundation, is a multi-institutional program that will map leftover light from the Big Bang in greater detail than ever. The project will allow scientists to see back in time to the earliest epoch in the history of the universe by viewing remnant light known as the cosmic microwave background. And an updated U.S. strategy for the Arctic region was released by the Biden administration on Friday. AMD predicts greater competition for power in that part of the world, brought on by climate change and growing military activity. The strategy updates the 2013 version and lays out a 10-year plan to position the United States to both effectively compete and manage tensions. The plan recommends investments in infrastructure to monitor the region and to improve connectivity, something the Defense Department and the U.S. Armed Services have already raised in their own Arctic strategies. The new strategy suggests infrastructure improvements will require investments in space-based communications and Earth monitoring. U.S. defense officials have pointed out there's a lot of value in supporting space systems for a region where there is little infrastructure. ASND, that's the news, Andrew.
Thanks, Halley. One wonders what they mean by the term manage tensions. All right, we'll catch up with you before the end of today's report. Now, back in 2013, the Dark Energy Survey started a 6-year mission, and their goal was to map thousands of galaxies, supernovae, and other patterns in the structure of the universe, in the cosmos. This was an international collaboration, and it was dedicated to investigating some mysterious phenomena, or a specific phenomenon that we know of as dark energy. And you've heard us talk about that before on Space Nuts, and we do not know much about it. But it is, at this point in time, a theoretical thing, but it accounts for 70% of the universe's energy mass density. Now, the main piece of instrumentation in this mission is a 570 megapixel dark energy camera, or the DE cam, and it's mounted on a 5-meter telescope in Chile. Now, between 2013 and 2019, the DE cam took over, wait for it, 1 million exposures of the southern night sky, and it photographed during that process around 2.5 billion astronomical objects, and that's everything from galaxies to comets, asteroids, dwarf planets, you name it. And the Dark Energy Survey recently released 15 spectacular images taken by the DE cam during its 6-year campaign. Now, those images showcase the capabilities of the camera and the types of objects it observed and the sheer beauty of the universe. I'm looking at some of them now, and they are just spectacular. And you might also be interested to know in this about this particular statistic. The Dark Energy Survey has imaged 1/8 of the sky. It's captured light from galaxies up to 8 billion light years away. The images it took were mostly focused on galaxies and galaxy clusters, the purpose of which is to track their movements over time. And in doing that, the DES hopes to measure the influence of dark energy on the distribution of matter in the cosmos. So still a work in progress. Now, while we're talking about the universe as a whole, astronomers have developed a way to detect ultraviolet background in the universe, which could help explain why there are so few small galaxies in the cosmos. I don't know if you're aware of that. UV radiation is invisible to us, but It shows up as visible red light when it interacts with pockets of gas. An international team led by the University of Durham in the UK has found a way to measure this particular UV background radiation using instruments on Earth. The researchers said their method can be used to measure the evolution of the UV background through cosmic time, mapping how and when it suppresses the formation of small galaxies. The study could help produce more accurate computer simulations of the evolution of the universe. UV radiation, which is a radiation that's also given off by our sun and why we have to wear sunscreen a lot, it's found throughout the universe, and it strips smaller galaxies of the gas that form stars. And they think that effectively means that these galaxies are stunted in terms of their growth. And it's believed to be the reason why some larger galaxies like the Milky Way don't have smaller companion galaxies. And they've been proving this through simulations at the university. And the findings have been published in the journal Monthly Notices of the Royal Astronomical Society.
The Astronomy Daily Podcast
with Andrew Dunkley.
A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Now, this is interesting with all the talk and work towards getting back to the moon and putting people back there. A bunch of Australian scientists have started working on a goal or a mission to grow plants on the moon. Yep, and they hope to do it in less than 4 years. The researchers say it could be a step forward towards growing plants for food, medicine, and, of course, most importantly, oxygen on the moon's surface and enable human life on our only natural satellite. Now, these are scientists from Queensland's University of Technology, RMIT, and the Australian National University in conjunction with Israel's Ben Gurion University, and they worked with an Australian startup company called Lunaria One on the project, which has been titled Aleph, A-L-E-P-H. And they'll choose a plant species that they can work with based on how it germinates and how it could tolerate extremes of temperature. The director of Lunaria One, Lauren Fell, said the goal was to put a shoebox-size hermetically sealed chamber or a lunarium, as against a terrarium, I guess, full of plants and seeds on the international spacecraft or on a international spacecraft headed to the moon. But before the plants get there, they're going to have to survive the grueling journey, which could be a challenge in itself. But maybe within 4 years, they'll be growing Earth plants on the moon for all those purposes. Oxygen is probably the key one, I imagine. But food, food especially. And finally, and this is so bizarre, police are investigating whether a woman in central Japan has been scammed out of $30,000 by a person, here it is, who claimed to be a Russian cosmonaut working on the International Space Station. Now, he's been chatting with this woman online through a line messaging app, and the person reportedly told her that they loved her and proposed marriage to her, but they needed $30,000 to get back to Earth. Now, this supposed cosmonaut said that the $30,000 was for landing fees. Well, they exist, in aviation at least. So she handed over the cash. But the person continued to ask her for money, and that's when she twigged and contacted the police, who are now investigating. They won't catch him. He's in space, isn't he? All right. That's just about it for today. Halley, anything else from you?
Yes, I was just thinking about that story you mentioned, about growing food on the moon. I imagine one day there might be a restaurant up there, but I think they'll have a problem with that.
Oh, yeah? What kind of problem?
Well, the food might be great, but the place probably won't have much atmosphere.
Oh, dear, oh dear. Bye, Halley.
See ya.
That's it for another day. Thanks for joining us on Astronomy Daily. Don't forget to chase up those stories and more on the Astronomy Daily tab on the spacenuts.io website. And while you're there, sign up for the newsletter so you get all that news delivered free to your inbox. And don't forget to leave your reviews through your favourite podcasting platform and catch up with the latest episode of Space Nuts while you're visiting our website as well. That's it from me, Andrew Dunkley. Thanks for joining us on another edition of Astronomy Daily. See you next time.
The Astronomy Daily Podcast
with Andrew Dunkley.